EES, which is pronounced ease, is an acronym for Engineering Equation Solver. Ease is an engineering tool, and therefore the variables in ease typically represent physical quantities, and these are often measured quantities. So we've seen how variables in ease can be assigned values and also units. But in ease, variables can also be assigned some uncertainty. The results of the calculations that involve these variables will themselves have some uncertainty, and the process of keeping track of how the uncertainty in the measured variables causes uncertainty in calculated variables is referred to as uncertainty propagation. Ease uses the most common technique for dealing with the propagation of uncertainty, which is called the root sum squares or RSS method. The RSS method assumes that the measurements are normally distributed quantities that are uncorrelated, and also that there are no systematic errors in the measurements. So then if the calculated quantity Q is a function of a whole bunch of variables, n variables, we'll call them x1 through xn, and each of these variables has its own uncertainty, which we'll call u sub x1, u sub x2 on through u sub xn, then the uncertainty in Q, which we're going to call u sub q, can be divided into its elemental uncertainties due to each of the measured quantities. So you would have a u sub q due to x1, a u sub q due to x2, all the way through to u sub q due to xn. The elemental uncertainty in Q due to measurement x sub I is just the product of the partial derivative of Q with respect to x sub I and the uncertainty in x sub I. So you can do all the elemental uncertainties in this way, and then you can finally combine them to provide the total uncertainty in Q by taking the square root of the sum of squares of each of the elemental uncertainties. And ease does all this for us automatically so that we don't have to do all of the underlying math. It's useful to know both the final total uncertainty in some calculated quantity as well as the elemental uncertainties, and ease will report all of that information to you. Sometimes knowing the elemental uncertainties can be really useful because it might tell you which of the various measurements that you're taking are the most critical in terms of calculating some final value. Ease automates this process of uncertainty propagation using the RSS technique. So let's illustrate this process with a real simple example. The mass of argon in a tank is to be calculated by measuring the pressure, temperature, and the internal volume of the tank. So these are three measurements. Each of these measurements will have some uncertainty associated with it. The temperature in the tank is measured to be 22.3 degrees Celsius, and it's measured with a thermocouple that has some uncertainty, which we'll call U sub T, and set equal to 1.2 Kelvin. The pressure in the tank is 934 kilopascals, and the pressure transducer used for that measurement has an uncertainty of U sub P equals 22 kilopascals. And finally, the internal volume of the tank is 10 liters, and the measurement or the estimation of this volume has an uncertainty of 0.4 liters. So we'll put all these measurements, all these inputs into ease, and these include both the measurement as well as the uncertainties. We're going to assume here that argon behaves as an ideal gas, which we don't have to. We could also use the internal property routines in ease. But if we assume it behaves as an ideal gas, then we can obtain the ideal gas constant as the ratio of the universal gas constant to the molar mass of argon. And then we'll compute the specific volume with the ideal gas law. And then finally we can compute the total mass of argon in the tank according to this equation. And if we solve now, we find that there is 0.1519 kilograms of argon in the tank, 151.9 grams. So we'd also like to know just how well we've estimated the mass, right? So what's the uncertainty in this calculated mass? And in order to do that, then we need to assign uncertainties to each of these measured variables and let ease take care of the propagation of this uncertainty through the calculations. So to do this, select uncertainty propagation from the calculate menu, and this will let you access this determine propagation of uncertainty dialog. The list of variables in the window over here on the right has been identified by ease as being at least candidates for measured variables, and therefore these are variables that you're allowed to assign some uncertainty to. The variables that initially populate this list are simply constants, so things that you set equal to a constant. They're independent then of all other variables. The variables in the window over here on the left are judged by ease to be things that are calculated. And there is the possibility that you might want to drag some variables from one list to another. And the variables that can be dragged between lists are indicated here in red. So here you could move specific volume from a calculated quantity to a measured quantity if you wanted to, and that would then allow you to assign an uncertainty directly to specific volume. So let's select from the list of measured variables those that have some uncertainty. So in this case, pressure, temperature, and volume. The maximum number of measured variables that you could assign uncertainty to is 30 in the commercial version of ease and 200 in the professional version. And then we'll select the Set Uncertainties button here in order to access the Uncertainties of Measured Variables dialog. So this is where we're actually going to do the setting of the uncertainties. You can set uncertainties either on an absolute basis or on a relative basis, and you can either use numerical constants or variables. The units column here provides the units for the measured variables, and these are the units that must be used when you set the uncertainty on an absolute basis. So here we're going to set the uncertainties using the variables that we had previously defined, so u sub p, u sub t, and u sub volume, which were assigned in the equations window. You select OK, and you can return to the Determine Propagation of Uncertainties dialog. Notice that if you have the professional version of ease, you also have open and save buttons that you can use to save and then later retrieve the uncertainty specifications. These are saved in a .unc file, and by using these files you can set uncertainties for one perhaps set of instruments and save those, and then if you have a different set of instruments you can save those uncertainties in a different .unc file, and you can just pick which file you want to use for the uncertainty propagation, so you don't have to retype those in. Select from the list of calculated variables in this window on the left the variables that you want to actually consider in the uncertainty analysis. So these are the ones that you'd like to know the uncertainty of. You can select up to 12 of these in the commercial version of ease and up to 50 of them in the professional version. So here we're going to select both the variables v, or specific volume, and m for mass. And then you select OK. Ease will initiate the calculations and then display a solution window, and the solution window includes the typical solution window, but it also has an additional tab which is labeled Uncertainty Results. And in the Uncertainty Results tab, you'll see what the uncertainty in the calculated variables are. So here we find that the specific volume is 0.0658 meters cubed per kilogram, and it has a total uncertainty which is shown here. The mass is again 0.1519 kilograms, and it has a total uncertainty of 0.0071 kilograms. What's also really nice, again, is that the source of these uncertainties is delineated for you. So, for example, here you can see that the vast majority of the mass, of the uncertainty in the mass, is related to the measurement of volume. So if you wanted to make this measurement more precise, if you wanted to know the mass more accurately, you would do something to improve your measurement of the volume of the tank. This is one of a series of tutorials that is meant to describe the operation of the ease software. And if you'd like to get more information about ease, obtain the software, or access more of these tutorials, please go to the website fchartsoftware.com. These tutorials are excerpted from the book Mastering Ease, which can also be obtained from this website.